If the measure of arc ADC is equal to 160 and the measure of arc EF is equal to 80, what is the measure of angle ABC? So in order to find the angle ABC, that is equal to 1/2 of the measure of this arc ADC minus the arc EF. So again, the measure of angle ABC, that is equal to 1/2 of the measure of the arc ADC, okay, this arc, minus the measure of the arc EF, okay, this one. So the measure of angle ABC is equal to 1/2, okay, times the measure of arc ADC is equal to 160 minus the measure of arc EF, which is 80. So measure of angle ABC is equal to 1/2 times 80. So therefore, the measure of angle ABC is equal to 40. If the measure of arc MTL is equal to 220 and the measure of arc ML is equal to 140, what is the measure of the angle MQL? Again, the measure of this angle MQL is equal to 1/2 times the measure of the arc MTL minus the measure of the arc ML. So we have the measure of angle MQL is equal to 1/2 times the measure of the arc MTL minus the measure of the arc ML. Okay. Angle MQL is equal to 1/2 times the measure of arc MTL, which is 220, minus the measure of arc ML, which is 140. The measure of angle MQL is equal to 1/2 times 80. So therefore, the measure of angle MQL is equal to 40. If the measure of arc PR equals 45 and the measure of arc QS is 49, what is the measure of angle PTR and the measure of angle RPS? Okay, now, since the angle PTR is inside the circle, so the formula is the measure of angle PTR is equal to 1/2 times the measure of arc PR plus the measure of arc QS. Again, the measure of angle PTR is equal to 1/2 times the measure of arc PR plus the measure of arc QS. Okay, so we have the measure of angle PTR is equal to 1/2 times the measure of arc PR, which is 45, plus the measure of QS, which is 49. Then measure of angle PTR is equal to 1/2 times 94 So therefore, the measure of angle PTR is equal to 47. Okay, how about the measure of angle RTS? Okay, since PTR is vertical angle to QTS and the measure of PTR is 47. Okay, this one is 47. So, this is also 47. Now, to get the angle RTS, so that is twice the measure of angle PTR plus twice the measure of angle RTS is equal to 360. Then, substitute the value of PTR, which is 47. We have 2 times 47 plus 2 times RTS is equal to 360. Then 2 times 47, so that is 94 plus 2 times the measure of angle RTS is equal to 360. Then twice the measure of angle RTS is equal to 360 minus 94. So, twice the measure of angle RTS is equal to 360 minus 94, so that is 266. Then, divided by 2. So, the measure of angle RTS is equal to 133. So, if the measure of RTS is 133, since RTS is vertical angle to PTQ, so therefore, the measure of this angle is also 133. Suppose the measure of arc CG equals 6x plus 5, and the measure of arc ER equals 4x plus 15, and the measure of angle AEC is equal to 115. Find x, the measure of arc CG, and the measure of arc ER. Okay. So, since we all know that in order to get the measure of this angle, so the measure of this angle, or this one, is equal to 1/2 times the measure of this arc plus the measure of this arc. So we have the measure of angle E is equal to 1/2 times the measure of arc CG plus the measure of arc ER. So the measure of angle E is equal to 1/2 times the measure of arc CG, which is 6x plus 5, plus the measure of arc ER, 4x plus 15. So that is equal to 1/2 times combine similar terms, so that is 10x plus 20. Then multiply, so that is the measure of angle E is equal to 5x plus 10. So we derive this angle E is equal to 5x plus 10 without knowing the specific measure of this angle E. So let's go back to the given uh, number. So angle AEC is equal to 120. So this measure, this angle, the measure is 120. So angle AEC is a vertical angle to angle GER. So therefore, the measure of this angle is also 120. Now, one complete revolution, that is equal to 360. So 360 minus the angle of AEC plus GER. So that is 360 minus 120 plus another 120, that is 240. And that is equal to 120. Then this 120, divide it by these two angles. So we're going to divide this by 2. That is equal to 60. So the measure of this angle is 60. And also this angle, the measure is 60. Now, if the measure of angle E is 60, so we have 60 is equal to 5x plus 10. Then 60 minus 10 is equal to 5x. Then 50 is equal to 5x. To solve for x, divide both sides of the equation by 5. So therefore, x is equal to 10. Okay, next, how about the measure of arc CG and arc ER? Okay, the measure of arc CG equals 6x plus 5. And the value of x is 10. So all you have to do is substitute the value of x. So we have the measure of arc CG equals 6 times 10 plus 5. So the measure of arc CG equals 60 plus 5. So that is equal to 65. Then for the measure of arc ER, that is equal to 4x plus 15. So the measure of arc ER was 4 times 10 plus 15. So the measure of arc ER was 40 plus 15, and that is equal to 55. if the measure of arc LGC is equal to 149 and the measure of angle LEC is equal to 39, what is the measure of arc MC? So again, the measure of this angle is equal to 1/2 times the measure of this arc minus the measure of this arc. So we have the measure of angle LEC is equal to 1/2 times the measure of arc LGC minus the measure of arc MC. So the unknown here is the measure of arc MC. So the measure of angle LEC is equal to 39, is equal to 1/2 times the measure of arc LGC. We have 149, okay, minus the measure of arc MC. Then apply the cross multiplication. So multiply 39 times 2, so that is 78, is equal to 149 minus the measure of arc in C. Then apply the addition property of equality. So from negative, this becomes positive. We have the measure of arc MC is equal to 149 minus 78. So therefore, the measure of arc MC is equal to 71. A line segment OK is tangent to circle R at C. Okay, suppose KC, this one, KC is congruent to OC. Then OK is equal to 56, and RC, this one, RC is equal to 24. We find OR, RS, and ES. So in order to find the measure of line segment RO, we can apply the Pythagorean theorem that C squared is equal to B squared plus B squared. C squared is our hypotenuse, the RO or OR. Then this is gonna be our A and this is our B. So we have C squared. So that is C is equal to the square root of A squared, which is 24. That's the measure of B. Our B is from C to O. So half of 56, so that is 28 squared. So we have C is equal to the square root of 576 plus 784. C is equal to the square root of 1360. C is equal to 36.8782, or C is equal to 4 in the square root of 85. So C or RO or OR. Okay, so this is our OR. Then how about the RS? So RS, the measure of RS, that is equal to 24 because that is a radius. Then for TS, that is equal to the measure of RO minus the measure of RS. RO minus RS. So TS is equal to 4 square root of 85 minus 24. If the measure of our Q in O is 238, what is the measure of PQO and the measure of PQR? Okay, so the measure of this PQO is equal to 1/2 to its intercepted arc. Since QO is unknown, so we have to find first the measure of this arc. So the measure of arc QO is equal to 360 minus the measure of Q in O, which is 238, and that is equal to 122. Okay, so the measure of this arc is equal to 122. Then next is find the measure of the angle PQO. PQO is equal to 1/2 times the measure of QO. So that is equal to 1/2 times 122. So the measure of angle PQO is equal to 61. Then how about the measure of PQR? The measure of angle PQR so the line R, so this one, the measure of this line is 180 degrees. So since the measure of PQO, so the PQR is equal to 180 minus 61, and that is equal to 119. Okay, segment PR is a diameter of circle O, and the measure of arc RW is equal to 55. Find A, the measure of arc PW. Okay, for A, the measure of arc PW, that is equal to, okay, since this diameter is semicircle, the measure is 180. 180 minus 55. So the measure of PW is equal to 125. Okay, how about for B? B, the measure of angle RPW, that is equal to 1/2 to its intercepted arc, which is RW. So 1/2 times RW, so that is equal to 1/2 times 55. So that is equal to 27.5. Okay, next, letter C. The measure of angle PRW. PRW that PRW that is equal to 1/2 to each intercepted arc, which is PW. So we have 1/2 times PW. So that is equal to 1/2 times 125. So the answer is 62.5. Okay, for D, the measure of angle WRE. Okay, WRE, the measure of this angle. Okay, so since this angle is a right angle, then its adjacent angle is also a right angle. So since the angle PRW is 62.5, then that is equal to 90 minus the measure of PR, the measure of angle PRW. So that is 90 minus the measure of this is 62.5. So therefore, the measure is 27.5. Okay, for E, the measure of angle WER. Okay, where's the WER? WER. Okay, WER. Okay. WER, that is equal to 1/2 times the measure of this arc PR minus the measure of WR. Okay. So 1/2. Again, the PR is 180 minus the measure of WR, which is 55. So that is equal to 1/2 times 125. So therefore the measure is equal to 62.5. Okay, for F, the measure of angle EWR. EWR. So that is equal to 180 minus the measure of angle WRE plus the measure of angle WER. So that is equal to 180 minus WRE, that is 27.5 plus WER, which is 62.5. So that is equal to 180 minus 90. So the measure is equal to 90. Okay, circles P and Q are tangent to each other at point S. AB is tangent to both circle P and circle Q at S. Okay, suppose AB is equal to 16, AP is equal to 12, and AQ is equal to 10. what is the length of PQ? This one. PQ is 8 by 6 AB. So by applying the Pythagorean theorem, so we can draw a triangle. So we have this one. So this is P, A, and S. Okay, so we have AP is 12, then AS is 8. So what is PS? So PS is equal to the square root of 12 squared minus 8 squared. So PS is equal to the square root of 144 minus 64. So PS is equal to the square root of 80, and that is equal to 4 and the square root of 5. Next is for this triangle. So this figure, we have this one. This is A, Q, and this for S. Okay, this 8, then 10. So what is the measure of this Q or QS? So QS is equal to the square root of, okay, the hypotenuse here is 10 A squared minus 8 squared. The QS is equal to the square root of 100 minus 64. The QS is equal to 36. The QS is equal to square root of 36. Then, what is the length of PQ? So PQ, that is equal to 6 plus 4 square root of 5. The length of QS, this one, plus this length, PS, and that is the length of PQ. AP is tangent to both circles T and J. That A. So this A is tangent to circle P and that is, and RT is tangent to circle J, R. If is T is 2x plus 7 and RT is equal to 3x plus 1, find x. So for A we have 2x plus 7 is equal to 3x plus 1. So, by applying the addition property of equality, that is 7 minus 1 is equal to 3x minus 2x. So, therefore, x is equal to 6. Therefore, B is T is equal to 2x plus 7. And x is equal to 6. Substitute. So that is 12. 12 plus 7. That is equal to 19. Okay, for C. The RT is equal to 3x plus 1. So that is equal to 3 times 6 plus 1. 18 plus 1. So that is equal to 19. And B for 80 is also equal to 19.